When I talked about the syntax of an aid statement, I kept using the term operand, but that's just a fancy word for data. The verbs in aid act on data, and we classify data by type and by form. Every data item can be described by both its type and its form. I'll describe data types first, because there are only two of them. One data type is alphanumeric, and the other is numeric. Alphanumeric data is any printable characters, and that includes letters like ABC, or numbers like 456, or punctuation like, well, exclamation, @sign, $sign, whatever. Numeric data uses only the numerals 0 through 9, and we also have a minus sign, or an oversigned character. Numeric data in aid is also a whole number, positive or negative, up to 14 digits in length. That ought to cover the gross national product if you're doing those types of calculations. The forms of data are a lot more interesting because now we're using our programming language effectively. In addition to being of type alpha or numeric, data in aid may be one of several different forms: a literal, a variable, a two-dimensional array, a field, an expression, or a function. Let's look at examples in our OpStop 6 program. The easiest form to spot and understand is the literal. A literal is constant data. It doesn't change. Alphanumeric literals are strings of characters enclosed in quotes. It doesn't matter if they're single or double quotes, so long as they match. Line 31 is an example. This string of characters between this quote and this quote is going to display on the screen. Alphanumeric literals are used often to assign values to variables, to make comparisons with input data, or to output text to a file or printer. A numeric literal is a string of numbers that doesn't have quotes around it. This digit 1 on line 26 is a numeric literal. This digit 1 on line 39 is an alphanumeric literal because it's enclosed in quotes. What's the difference? It's in how aid stores and interprets the data. Aid can't do arithmetic with this one in quotes, but it can with the one that doesn't have quotes. Variables are far more interesting, as they are what make a programming language powerful. A variable is a storage space to which data is moved. You identify that storage space with a name. For example, bdate and edate are variable names. So are flag, line, and key. Unibase has some conventions for naming variables. A variable name has to start with an alpha character. Then it can have alpha or numeric characters following. It can be up to 31 characters long. The only punctuation symbol allowed is the underscore, and the name cannot be one of aid's reserved words. The storage space reserved by a variable name is temporary, only available and used while the program is executing. That's because the storage space for the variable is in memory. When the program is finished executing, that memory is used for something else. The type of the variable is determined by what's moved to it. For example, the variable FLG and LINE are of type numeric because numeric literals have been moved to them. The variable names key and name are of type alphanumeric because alphanumeric data has been moved to them. You can keep changing the data moved to a variable. That's the neat part, and that's why it's called a variable. You vary the value of the data in it, and you can vary the type of data in it. Look at the variable key. First we moved 11 spaces to it. Then we moved something called operator to the first 10 characters, and then we moved the alphabetic literal 1 to the 11th character of key. An alphanumeric literal and an alphanumeric variable can hold up to 120 characters of alphanumeric data. A numeric literal and a numeric variable can hold up to 14 digits of numeric data. I mentioned arrays, but there are no arrays in our OpStop6 program. That's a form of data covered in Advanced Unibase, and it's possible to do a lot of programming without needing an array anyway. All programming languages have literals and variables of some sort, even though the syntax to refer to them might be different. In Unibase, we want to manipulate all that data our operators keyed. Each field of data in a record is referenced by its field number with parentheses around it. For example, in this line, we're referencing field 9 in the record, and the following line is referencing field 10. Remember in earlier lessons that I kept stressing that Unibase numbers data fields sequentially in a format, left to right, top to bottom, as they're painted on the screen. These are the numbers used to refer to the data in the fields. A field is also storage space, but it's not temporary. The data in a Unibase file is stored on disk and is always available to us. A field can be from 1 to 99 characters long, and there can be up to 999 fields in a record. The data in these fields are always stored as alphanumeric data. Another form of data is an expression. It's just several operands strung together to form another operand. In this program, and in these particular lines, we have arithmetic expressions. These statements operate on two items of data to produce a single operand. The operation is arithmetic and denoted by symbols. Now we're back to grade school math. We use the plus sign for add, the dash for minus, an asterisk for multiply instead of the letter X, and the forward slash for divide instead of the divided by symbol, which doesn't exist as a key on the keyboard. So, in our first move statement, we think we see 3 operands, but else x divided by 60 is operand 1 because the final result is being moved to operand 2, which is temp 1. Else x divided by 60 is the expression. We don't call else x operand 1 and 60 operand 2. We also have examples of subtraction and multiplication expressions. This is the subtraction, this is the multiplication. Same thing here and here. An expression is one of those useful words mathematicians invented so they didn't have to keep saying arithmetically operate on several items of data to produce a single result. So we've mentioned arithmetic expressions. We have another kind, a relational expression. And we can show you a relational expression in our program. For example, we have this conditional statement, if L hours equals 0, and L hours equals 0 is called the relational expression. The relational symbols are the equal sign, as in this line, or the not equal sign, as used in the line below, and the less than and greater than symbols. For example, the less than symbol as it's used in line 174, where we say if line is less than 60. And yes, we often reuse the same symbols. Earlier I called these two symbols angle brackets and said they denoted a control function. Now I'm saying that they are relational symbols less than and greater than. Describing the concepts gets a little strange. Fortunately, using them is easier. You can tell what's happening by the context. One more concept, and we'll actually create some code in the next lesson. I had mentioned that a function could be a form of data. In Unibase, I'm referring to some of our control functions. You can get system information with a control function, such as the date or time or operator ID, and move it to a variable, or compare it to something else in a relational expression. You can get information about the batch from a control function, or insert new information into some of the control functions. For example, in this line, we're using the control function date4. It's operand 1 in this statement, and we're moving its variable to the variable date. There's a lot of power in the A language. Some of it is rather abstruse, and you may never need it. So we'll start simple and see if we can teach the world to sing, or at least tell it hello.